All right, let's look at 12b. Let's start by getting information from f of x. Factor this because we want our x-intercept, so let's factor this. So what can we pull out? Well, I guess we can pull out x squared. So here we have x squared, and here we have 3x squared minus 20x plus 36. And if you do b squared minus 4ac, you'll see it's less than 0, so this can't be factored. Nothing coming out of here. No real solutions from here, so just from here, just x equals 0 will go on the number line. So, just x equals 0 is the x-intercept, so that's the only x-intercept. And the y-intercept is y equals 0. Now, in behavior, it's up on the right, up on the left. All right, so as x goes to infinity, so does 3x to the fourth. And it's the same story as x goes to minus infinity because of that even exponent. So up on the right, up on the left. All right, let's do f prime. Here we have 4x cubed for the derivative of the first term minus 60x squared plus 72x. All right, let's factor. We can factor out 4x actually. We want to know where is this equal to 0. Sorry, let me correct that. Here we have 4 times 3. That's a 12x squared right here. So let me just change that. All right, so actually we can factor out 12x. So if we do that, here we have x squared minus 5x plus 6. All right, this factors to x minus 3, x minus 2. So we see we have, for critical values, we have 0, 3, and 2. And we'll put those on the number line. And we get that alternating pattern. Decreasing, increasing, decreasing, increasing. Here's a min. Here's a max. And we substitute in 2, we get 32. And here's a min. Okay. Let's do the second derivative. Okay, so here we have 3 times 12, that's 36x squared minus 120x plus 72. And we want to know where is this equal to 0. Well, here we can factor out a 12. And we have 3x squared minus 10x plus 6. Here we can factor using quadratic formula, or we can get the zeros using quadratic formula, and we have x is equal to 10 plus or minus square root 28 over 6, and this reduces to 5, just dividing, this is a 28 here. If we simplify this radical, pull out, write this as 4 times 7, this is 2 root 7. Let me just do that, 2 root 7. So divide top and bottom by 2, and we have 5 plus or minus square root 7 over 3. Okay, so this is approximately 5 plus is approximately 0.8. sorry, 2.5. And 5 minus is approximately 0.8. So we're just approximating these values. Let's do our plus minus analysis. And we get that pattern. So here we have concave up, down, up. And finally, we're going to put all the information together and draw the curve. Okay, we'll put in the x-intercept, and that's the x and the y-intercept actually, and then the end behavior just going up on both sides. So that's all we got from f of x. We're going to move on to f prime of x. Okay, here's our f prime information. We had a min at 0, 0. So I'll draw that min. We have a max at 232. All right, we won't draw this to scale. Let's say 32 is over here. There's our max. And a min at 327. All right, so that's 2, here's 3. Let's say 27 is over here. And that's a min. Okay, 3, 27. And I guess we're expecting an inflection point here. See, we have concave down, concave up. So we're expecting an inflection point right over here. And maybe right here as well. It's going to go down and up again. So it looks like the curve, if we just sort of attach the pieces, including this end behavior, it's going to go up like this. And let's attach it down to here. And then it's going to go up like this. So I guess we have an inflection point. We're looking for one here and one over here. Okay, let's check where our inflection points are now. This is f double prime. We have inflection points at 2.5. Okay, that's just where we expected it, between 2 and 3. And at 0.8, okay, that's here, more or less, where we expected it. All right, let's check the y-coordinates of those inflection points. Did we figure that out? Just 1 minute. Okay, with the aid of a calculator, here are 2 inflection points. So these are both inflection. And let's see. So here's our inflection point at 0.8 and 1.23. So it's actually way down here. Not what we expected, but it's way down here. Okay, it's over here somewhere. That's one inflection point, and the other 2.5 over here, and up at 29.7. We wanted it to be between 32 and 27, so that makes sense. That's the other inflection point. Okay, so that's the curve. That's the graph.